All right. Hello, everybody. Hello, from our favorite artist electronist, Mr. Q12, with a new and very interesting movie about a driver, 7-segment LCD driver, to be more specific and more exact. But this driver is special because I never heard of it, I never worked with it. This is the first, absolutely the first time in my life when I'm hearing about it, when I'm working with it. It's a bit special in the sense that it can drive up to 16 displays or numbers or digits. Right now in this picture, what you are seeing here is the first test I did with this chip. But let's go to the beginning and tell you the story about it. I don't exactly remember exactly. I believe I was watching a movie on YouTube and the guy was repairing some stuff. I don't remember even what he was repairing. That thing that he was repairing was having probably this chip, and probably I saw it at that guy. I don't remember this part. From where the hell did I find out about this chip? Or maybe ChatGPT suggested me this driver. The important thing is that I'm having it, and the chip is a bit weird. This is the name of the chip, TM1640. I'm showing you this because I want you to see how much I paid for 10 pieces. I paid $2.45. It arrived at 14 August and I put the command at July 24. So about 3 weeks it arrived. And here is the actual page. For 10 pieces is 0.86 per lot, plus shipping is 164. So how much this was? 245. Yeah, exactly. If you add this to numbers, you will get the same result here. This is the actual name, TM1614. Very interesting and a little bit weird chip. Before the chip arrived to me, I tried to find it and train myself in Proteus. And in Proteus, I had a very big problem. This is the Proteus file. This one. It's having two names, TM1614. Remember this name because this is my chip. The other chips I'm referencing, they are specific to other programs or other events. I put a Simulino here, which is actually the Arduino board, but it's having a different name in this simulator here. But it's the same thing. Load the program here, the hex program. Right now I cannot play it, unfortunately. So pretty much I didn't know how to wire this thing. I had to look on internet on other videos from some Indians, and I find the way they linked it. And it's a pretty weird story. Let me actually find, if I can find it, because I did this a long time ago. 7, I believe. Yeah, you see this guy and this guy, and they're showing here, and in their simulation is actually working. You see the numbers are running there, and exactly is using my Simulino Uno model Arduino that I'm having. This other guy, these numbers are changing through the outputs of this chip, and you can see the outputs there. I can actually zoom in a little bit and you can see that is having a negative and a positive. So, and also here on the other end of the wire, these guys, they have their chip working, but in my case I'm only having gray pins. On each output pin I have a gray square. Gray square, it means is floating, neither negative neither positive, none of them pretty much. So I couldn't test my chip at all. The only signals I had only on these two lines, and they were also weird. I believe until I put these two resistors, they balanced a little bit the input signals, but before them or without them, the inputs were also gray as well, which was a bit more weird because I was clearly sending some signal. I actually put a scope here in the simulator. I tested these pins, and this device here was running the program fine, like my note here. The program was running fine, but I was getting a lot of very weird behavior from this component. And the conclusion, I cannot run it right now because I actually have to load this program that is compiled in Arduino, and I don't have it anymore. I mean, I have it, but I have to do a bunch of steps. Try to believe me, this is the truth. This integrated circuit, this model of this brand is not in Proteus Simulator. Just to show you, let's erase a couple of numbers. So I will erase the 7, is also showing only one chip, and I'm erasing the two numbers. So TM16, let's erase another one, TM1. You see here, it's also showing only one chip. So my version of Proteus contains only this version of the chip, 1637. And that's why you are seeing here this two names, 1640, which is my chip, but 1637 is the only chip available in Proteus Simulator. Let me show you the version. So release 8.13, service pack 0, probably build 31525. I'm having actually Windows 11, but the program believes it's still Windows 10 because Windows 11 is a shell over Windows 10. Most probably that's why he is recognizing it as Windows 10 and not 11. This is the version I'm having for this program, and after I watched, I was very confused on why the fuck these guys on the internet, and even 2 years ago, you see this guy 1 year ago, why the fuck these guys are having working integrated circuit here and mine is not working in my simulation. And then I take a closer look on the program interface, and you see the interface is very different from mine, and this kind of interface is a newer interface, most probably is version 9 of this Proteus program. And the same with this guy, is also having a bit more bigger user interface, but it's still different from what I'm having, the old style, and is also version 9. So they have this version 9 of Proteus. That's why their chips are working, are simulatable, and mine is not. What I did, I searched on internet for this chip, hopefully to find it and to add it in my version of Proteus. This is a note here. This IC component is not working here in this simulation. In this simulator, in the entire simulator, is the only chip that is having and is also not working. I actually find one chip from one website. I forget its name. I downloaded it. I installed it. I replaced this default one with that other one. When I tried to run it, it didn't run because it didn't have a simulation. So you see here, VSM DLL model. It means it can be simulated, but but that component that I find was saying here, instead of this DLL model, it said here no simulation available. I could not simulate it. I could see the component, I could place it in my schematic, but I could not simulate it. It didn't let me to simulate it. It was basically the same thing what I'm having here, but that was worse. At least this one is not working at all, but at least I can simulate it. At least I can run the program with it and not having that error popping out. Then I installed Proteus version 9, but the demo mode, and I run it, and I find the exact same chip there, and exactly like in my version, only one chip, this TM1637, it was there. And when I place it in the form here on the canvas and I try to simulate it and I run the program, guess what I got? I got an error about the DLL that you have to pay for it to be able to run it or access it, enter and use it pretty much. So that's the problem. That's the real problem, because that version 9 from my version 8 is not that far away, and most probably this chip here is exactly the same thing as that other one. Is probably for special people to pay for it to work, probably, it's my guess, and they don't say it here in this version. You must have the knowledge or the right people around you to tell you these things, but I don't have these right people around me, and I don't know these things, and I have to guess big time what the hell is going on, why this fucker is not working. It's not because it's a damaged component. I believe it is working pretty well, but it is not available. It's not a buy. I cannot buy it to have it in my free simulation. So that's the little dark story about the chip inside the simulator. But at least with this exercise that I have here, even if it's a bit different from my version of the chip, remember my chip is 1640, but at least I understood how to make the wiring, how to make the schematic with all this trouble that I tried to solve. And the pinouts from this 37 to my 40 chip are very, very similar, especially for the input data and for the grid and for this segment outputs that you can read the naming of them. You see segment here outputs or keyboard inputs. K, it means keyboard, and this one. My chip is not having a keyboard, but this one is having. So that's the difference between them. But this clock and DIO pins, which are the communication with the microcontroller input pins, maybe only this one, the clock one, is the input, but data in out is input and output, as the name suggests there. And this K1 and K2 are inputs for the keyboard, which I'm not concentrated to test at this moment. I actually tried to test on my chip because ChatGPT was giving me a lot of false information, a lot of garbage information about the chip features. He wrongfully assumed that my chip was able to receive keyboard inputs, and then I had to learn this little detail that the other chips in this series of chips, remember, this is my first time working with this chip. I have no idea what it's doing, how to work with it. I was completely blank, completely zero about it. I had no idea what the fuck is going on. A couple of buttons, two buttons I linked on my breadboard and I tested them. Then I realized I had to go back to other names of the chip, including this one, 1637, and realize that they have special keyboard naming on their pins, like this K that you are seeing here, K masters, and this other K per segment. But this 8 here and this 2, and it's 8 by 2. You can maximum put 16 buttons pretty much on this chip. It's like a grid. It's pretty interesting. I'm not sure if you can drive in the same time the keyboard and the display. So that's it about the Proteus simulation and the experience, the little black experience with it, until I understood what the fuck is going on. Yeah, here I was testing actually this groove, a 4-digit type. You see, it's a bit different from this other two, and this is common cathode and this is common anode, and I was testing them separately, and they are all working in this form, like I'm testing them here, but they didn't work here at all with the chip linked. And here, this is for a picture, for the screenshot when I made the circuit, to have it, to look at it while I was making my 1640 circuit. So that's what I used this Proteus simulation, only for the circuit drawing, and that's it. Also, I have here a note. TM1640 is what I have, the chip I have. TM1637 is the only Proteus chip that is not working at all. On internet, no free simulation component either. I did find free component, but like I said, it was not able to be simulated. I also searched into Proteus 9, and the DLL is license password locked. That was the problem, and I believe it's the same problem here as well. Only that here I'm not getting a detailed error like in Proteus 9. Here is just nothing. Then I have this 1, 2, 3 files. As you can read from the name, this is my datasheet for my chip. This version 38. This is the Proteus version chip. But this is the other chip that I put my eyes on it. And this one is saying clearly here, keypad scanning 8 by 3. Let me actually show you this 37. You see here the keyboard scan 8 by 2 bits. It means 16 buttons. So this is the one from Proteus. This 6-bit is not correctly named here 6-bit. It refers to 6 grids. And 8 segments is the 7-segment display plus decimal point, so it means 8 segments. So this is correct naming 8 segments, but 6-bit it means 6 grids. You can see them here, grid 1, 2, 3, 4, 5, 6, and you can drive only 6 numbers, 6 digits with this chip. So 1637 comparative with my chip 1640, and it's 8 section is calling it. They are very, very weird on naming. It means 8 segments by 16 grids, and I can drive 16 displays or 16 numbers or digits with my chip. This is the most advanced chip they have. And this other one, 1638, is having 10 segments. It means 10 grids by 8 bits, which it means by 8 segments, and it can drive 10 digits. So mine is 16, this is 10, and the other one was 6 from Proteus. So this is the number 2 most advanced chip, TM1638, from this brand, Titan Microelectronics. This is the first time I'm hearing about them, the first time I'm working with these chips, and I'm pretty new. I'm very, very new to them. I can tell you, 1640, this chip that I'm having was a little bit weird in the very, very beginning. So I have these 2 pictures here. This common cathode and this other one common anode. And in this datasheet for my 1640, it says that it supports common cathode here. But I wasn't actually very sure. I didn't know what to believe. Maybe it's good for common anode as well, even if it says there common cathode. I wasn't 100% sure it's only for common cathode. That's what I was thinking at that time. Again, this is very early, very beginning, starting to work with this chip. And ChatGPT again was throwing me a lot of false information that this guy is able to drive common anode displays, while in reality is built only for common cathode, and that's it. There are some other chips from this TM series that can drive common anode only, or common cathode and common anode, both types in one chip, but my version can only drive common cathode displays. So he was a bit messed up, ChatGPT, by believing my chip can do it the same. It made me believe might be a hack somewhere how to drive it, but after more discussion with the ChatGPT, I came to the conclusion they are built to drive common cathode and common anode displays, not to fuck around, to try to repurpose. If it was built like that, respect the way it was built and use the right chip to drive the right display. That's the conclusion I learned from ChatGPT. So digital tubes, this is from 1940 naming. You can probably drive even vacuum tubes with it, but this is made specifically for LED displays. Shown in the diagram are common cathode digital tubes. What the fuck? 1940. This is the only mentioning about the type of the display, and it's very, very, very important because you will fuck it up. As I was scared, I fucked it up myself for a very long time because of that idiot of ChatGPT who messed up everything. He thrown me garbage information that this chip, my version, is able to drive common anode, while in reality is made for common cathode displays, and that's it. This is a very important information that you don't joke about it. You must have it clear in your mind what it's doing and how it's doing it. So let me actually show you and compare my version, which is TM1640. This is the Proteus chip 1637. The display mode is actually mentioning here in the futures, but if we are looking, it is actually specifying common cathode for this as well here. My bad. But I find other data sheets for other TM numbers that they don't specify. I believe is this other one. Yeah, you see, 10 segments, 8-bit display is not mentioning if it's common cathode or common anode for this 1638. These are little cunts who made these data sheets. Let me actually show you and make the difference what is common anode and what is common cathode. Common anode is coming through 1K resistor. I want to insist on showing you that I actually put in my diagram, I put this 1K, it's the minimum of resistance. You must add it on this common pin of the display, and also from this other side you have to put 1K if you are linking it from this other side. So 1K is okay to have it. If you link it here on top, you leave this pin floating. You don't have to link it to positive or anything like that. And the rest of the pins are commanded through negative signals, which is shitty. This is the shitty display. I don't like it. Me personally, I don't like it. But there are cases, most probably in this world and in general electronics, where you have the need to use this type of display with negative inputs. It's like a PNP version of the transistor that nobody uses them. Only NPNs are the most used ones. And this is the common cathode, which is my version of the chip 1640. I'm linking again 1 kilo on one of its grid pins or common pin. Here 1 kilo or there, and this other pin is floating if I put 1 kilo there. And the other pins are commanded through a positive signal, which is the normal way of commanding anything. In my book, at least, it is the most intuitive way of commanding anything. This version is fucked up. I don't like it, but this version is the normal way of and most intuitive and most easy and pleasant to drive it. And that's what I'm saying with my little presentation here. So that's what you need, a common cathode usually. And my display, TM1640, is common cathode, is for this type of displays. This one is specifically for common anode. The fucked up one, where are you? This fucked up anode one, which I don't like it. The problem is that I have 20 of them, single digits like this, exactly in this format with these pins that you are seeing it here in my picture. And I have 20 of them. Why? Because they were extremely dirt cheap. Because most probably they were not selling, and they lowered the price just to get rid of them. That's my impression. That's my conclusion after trying to work with them, and it was hell on earth to work with this type of, because everything is inverted and you have to think inverse. You know, you have to pay extra concentration and extra effort and extra attention. How to link everything is more extra than normal. That's what I'm saying. When you have to command this type of components with negative signals, that's the problem. If you are putting positive on the negative, you either make a short, or in the best case scenario, it will not work and not make any shorts. But usually you will make a fucking short, and that's the biggest reason reason you have to pay extra mega attention on these types of components. Doesn't matter what they are, digit displays like I'm having here, or something else, or transistors, or other chips, whatever they are. So the problem is that I have 20 of them. They were extremely cheap. I buy them. The first digital displays I had in my arsenal was these motherfuckers, these types, and it was hell. It was shit to drive them. I never liked them because of their way of driving. I didn't even use one. I only tested them on breadboard, and the rest, they are brand new in my box there. I never put my hands on them. And then I realized there are the other types, the common cathode, like this one, that you are properly driving them with positive signals per pin. You come on their negative. This one, you leave it floated. Either one, you link to the negative. This is the normal way of driving it, the normal way of thinking how to drive it. I paid a bit more attention to this version. This is the Proteus version. And that's why the Proteus version is having this shitty version of this chip that is driving only the common anode displays and not the common cathode, which is the normal way. And I was thinking to buy this version, but because my Proteus simulation is not allowing me to drive this chip, I thought maybe it's a good idea to search even more and compare even more other chips from this brand, TM brand, other numbers. And this is the other guy that I put my eyes on, and I actually bought 20 of them because I can drive less segments than my 1640. So this 1638, I can drive 10 displays, 10 numbers. But this guy is very interesting because, let's say, as you can see, here is not mentioning which type is driving, if it's common cathode or common anode. And it doesn't mention anything here in the introduction. It should, but it doesn't. But if you are scrolling down, what I did find, display, you see here, chapter 7, display at page 6. Number 1, driving common cathode, and number 2, common anode. So I said, aha, motherfuckers. This chip is actually able to drive both of these types of displays. So this is very, very interesting. Also, keypad scanning as well is able to drive 3 times 8. It means 24 buttons, which is a bit more advanced from the other one, 37, that was in Proteus. But my chip 1640 cannot drive any keyboard. I remember I showed you here, it doesn't have any K marking, K for keyboard. And this is the circuit. This is the chip here in the middle. These are the displays, and these are the buttons. So this is for common cathode, and here is common anode. So this is confirming that it can drive both of these types of displays. And I was very impressed by it, but it is a little problem because here, the common cathode, there are many, many nuances, many little details about these chips I didn't know, and I had to learn about them. This common cathode, my version is able to drive 18 displays, but this guy is showing here only 8 for some reason. So you see, segment 9 and segment 10 is not linked to any displays, which is pretty shitty, but it's good enough, only 8 of them common cathode. But I have this other guy that he can fulfill this role of driving a ton of common cathode displays. But on the common anode is showing all 10 of them, all 10 digits, all 10 numbers. And you can see segment 9 and segment 10 here, they are linked. There are other versions, other numbers here, but this is the one that I bought, and I bought 20 of them because it's quite cheap. You see, 2 times 10 pks, it means 20 pks. TM1638, exactly this model, and I paid for 20 pks, I paid 3.73. So it's not really that big of a budget. I believe they changed the price on it, because you see, 143 plus 0.69 there, that's the shipping, and I paid 2.12 per 10, and per 20 I paid 3.73, but now it's 2.59. They changed their pricing from yesterday, I believe, after I put the command. I hope they will send them to me. Usually they are creating an error, a system error, and I'm waiting like an idiot, and after 1 month or 3 weeks, when I'm asking them if the package is on the transit, they will tell me, no, sorry, your package never was sent. It's because of changing in pricing. They are changing literally in their minds. It happened to me a couple of times. They are little motherfuckers. Some of them, not all of them. Some of them are okay. They are sending you with the low price that you catch, and then after you, they will change whatever they please, little bastards, not sending me the product. So these are the different models of this chip that I had to navigate through them. I had to understand them, and all this trouble, it took me about 1 week already on dealing with this chip, on learning this chip and its cousins, that they are doing way more different stuff than my version that I'm having. And it was quite intense learning curve. But now, after I learned it, it's not that weird chip anymore. Let me get back to the beginning when I mentioned that this is a weird chip. Like you are seeing here, I'm having this 1 kilo resistor everywhere. When I'm connecting this display to anything, I'm adding automatically without thinking. I'm adding at least 1 kilo here, and even bigger values like 5 kilo or even 10 kilo I'm adding to this pin. But in my case, I linked to this chip that 1 kilo. Here is a little pad. You can actually read there probably 1 kilo. And I had the SMD 1 kilo there, and this black wire was linked here. You can actually see a little arrow that is pointing where I should put, that's the output where I linked originally this black wire that you are seeing here. I was linking it here, and it was passing through that 1 kilo and then into the chip. And as you can see, I'm only using one grid 1 here. Let me bring up its datasheet here, and you see here, this is positive 5 volts third pin, and the fourth pin is grid 1 and is counting up and then down here, down to 16. So it's 1, 2, 3, 4 is the fourth pin on the grid 1. Okay, the other wires are underneath. That's why you cannot see shit here. So I put that resistor automatically. You know, that's how I learned to drive any LED. And these displays LEDs are more expensive than a simple LED. My intention is not to burn them. I try to protect them. And this little detail I had no idea is not specified in the datasheet, or if it's specified, is not clear, is not in the first lines here. Is not marked. Do not fucking use any kind of resistors on the grid pins or the segment pins to drive the LED displays. And the display didn't work, didn't lit up. I was programming it, I was questioning the programs I was using, I was questioning everything. And on this little board you see here, I don't have a number on this chip, but later I put a number on it because I tested the two chips. I tried like a ton of permutations. I tried to make it work, probably half of a day, like 5 or 6 hours, until I realized that little fucking resistor was the problem. I was thinking maybe these chips are 3.3 volts, maybe it's not 5 volts. And I was discussing with ChatGPT, I was asking all these questions, why is the fuck is not working? And he was throwing me a lot of garbage information. But even if he threw me a lot of garbage information, it did throw me some good ones that you have to heavily filter them out. If you are talking with ChatGPT, learn from my experience, and you have to manage to filter the good stuff that he is telling you. And he is telling you between the lines. It's not that evident, it's not that clear. And you have to decide what is very important and what is less important and what is shit, pretty much. And you have to remember everything he's telling you in a good amount, in a normal good amount. All right, so after half a day of trying and errors, it was not pleasant, it was not nice, but I figured it out. In the very end, I figured it out that internally, most probably, that's the only explanation, that internally this chip is using at least 1 kilo resistor for the display, current limiter for the displays that are linked to its pins, with great untrusty hands. My hands were trembling of untrust. I linked this wire directly to the pin, and I was sincerely expecting this display to blow up. And it lit up fully, like you are seeing it here in this picture. And it was like a shock for me. How, why, how the fuck, who is the idiot who is not mentioning this little detail at least in the datasheet? Yeah, I was, oh wow. I was very frustrated, I was very annoyed, and I was very mad. And that's why I mentioned that these chips are a bit weird from this point of view, how to link them. At least the displays, how to link to their pins without that current limiting resistor. So this was the very odd part, very weird part that I stumbled upon, and I got over it very hard actually. It cost me half a day to realize how to do it properly. I should have read the datasheet more thoroughly. I did fly over the datasheet, but I didn't read it very seriously. Maybe there is some mention somewhere there in the datasheet, somewhere here, but I didn't read it very seriously. I fly over it. I only sniped a couple of important things that is doing. All right, this is another shot when I made it working. It's showing you a weird number here, or a weird character, because I was testing actually. Yeah, you see a list of programs here, and I have here what each program is doing up to 9, a list of programs. So for one display, you see I'm having for one display, on one display. So 4 programs for this arrangement. What I did here, I made 4 programs, 4 tests. 2 of them I know for sure. So this one and this one, as you can see, they are bit banks. I use a bit bank code with the help of ChatGPT. Of course, I couldn't write it myself. That's why I moved relatively quickly with the help of ChatGPT, as shitty as it is, but it is doing a great job at coding at least. Now this is actually the third program, because the first program I could not get the brightness working. All that was for that brightness to work was this address 0x44. Write data with fixed address instead of 040 auto increment. Where is this 0x44? Is somewhere here. Motherfucker, my screen recorder stopped when I tried to search for this. Yeah, it's Windows fucking 11 and it's making a lot of fucking bastards. I'm having a ton of errors from Windows 11, that's why. Okay, so 044, write data. So this is the binary here actually of this address 044. Write data with fixed address to work with this with only one single display. It's apparently it is not made, this chip is not made to be used like I'm using it here with one single display. It is made to be used with a multiple of displays. Ideally, with maximum it can give 16 of them, or at least 2 from the theoretical assumption. This is my assumption, this is my guess. It is the minimum 2 of displays you can run with this chip, not one like I'm doing this test here. So this was another oddity, another odd thing I stumbled upon, and I had to deal with this problem. Like is mentioned here, this is not actually the first program, because I didn't manage to drive this display correctly the first round. Actually, it worked on one display, but the other functions of lowering the brightness was not working absolutely at all. But by changing this address here, from 040 into 044 like it is right now, to set it up as a fixed address, not auto-incrementing address. It did the trick. It did lower the intensity of the LEDs, and it's not that great. You are not losing anything, to be sincere, but it is, in the same time, it is a very interesting option this chip is giving you to lower the intensity. Is PWMing the LEDs, but it's a crude and shitty PWM. It's not a smooth. 8, 7, 6, and 5 modes are full brightness, and then from 5 down, like 4, 3, 2, 1, it's having 8 modes, and only the first 4 are visible brightness changing. The other 4 are fully lit, pretty much. If it's a difference is very shitty difference, very little, very small difference, imperceptible difference, and it's not really doing a good job at other higher levels. But at lower levels, it's quite evident, it's quite okay, relatively okay. I'm not I'm not impressed of the dimming or the brightness function of this chip, but it's having this function, it's having this option, and it's interesting. It's interesting that it can do it. But for it to work, you have to set it properly with this address, which is a bit shitty. To figure it out. It was also a couple of hours until I figured this shit out. Another 3 or 4 hours. Like I said already, this entire testings that I did here, it took me like 1 week, but I got extremely advanced in knowing this chip and understanding this chip. And now, after I understand it and after I know it well enough, I think it's a very nice chip, actually. It's a very nice chip. And that's why I'm building right now another test circuit for it without stupid mistakes like I did the first tries when I was testing this single digit. And it will be glorious, you will see. A glorious achievement from Q12 era, epoch. All right, let's see the next. I made a picture of the Arduino pins 2 and 4. This green wire is also a common negative as well. This is very important to have this common negative, but I link it there just from my general knowledge. Usually every chip that you are commanding from a microcontroller, pretty much, it doesn't matter if it's Arduino or something else, you have to link its negative rail to the microcontroller negative rail to have common ground, pretty much. That's a general knowledge that I have it from very long time, actually, and I didn't actually use it or put it in practice all the time, but after some while I took it seriously and I did use it all the time, and it worked. I didn't have any problems after that. But before, when I was not connecting it, I was having a lot of problems. Some chips were working, some chips were not working, and I didn't understand why. It's because this common ground wire is very important to have it. You can see here, you can probably see there are true hole components and not SMD components on the cardboard. It's because I made another mistake with this first chip when the display was not working, and I completely forgot about the resistors, pull-up resistors. So if we are looking here on the diagram, we can see these 2 pull-up resistors on both these data lines to 5 volts, and also 2 capacitors. I did not include these guys. I did not put them at all. Not in this version, the first version, not in the other versions that I built after that. I should put them. And also here on the positive and negative line, 100 microfarads and 1 microfarad. Pretty much here on the VDD and ground, very close to the chip, ideally, but in my case, it's not that ideal. From what I read, you can have maximum 5 centimeters, 3, 4, 5 centimeters, like that distance is the maximum distance you can put these filtering capacitors relative to the pins of the chip. So in this range, you are allowed to add them. Usually, the best thing is to add them as close as possible, but the tolerance viewing of the situation, you can actually leave a little bit of length, and it will do the same job. And this is what you are seeing here. I completely forget about these guys. I was linking directly the positive and negative. That's another reason I thought my circuit is not working, because of these components. I didn't add them. And later, I add them like you are seeing them here, practically in air. They are linked like that. When I was having that 1 kilo resistor, I didn't know about its role there. I thought the chip is burned. And as you can see, on this cardboard, I literally replace it. I took out this chip because I was thinking it's burned. That's why my display was not working. Actually, it was giving me some false, erroneous readings. Sometimes it was displaying a very extremely faint numbers. Most of the cases was not lighting the display. So I thought that chip was definitely burned. So I took it out and I put another one here. This is actually the second chip that you are seeing right now here in the picture. The second chip, I linked it here, and then I discovered with the second chip mounted here, I discovered that 1 kilo problem. And I discovered I didn't put any resistors, any filtering here, and because I was stupid, I literally forget about it. I was concentrated on the pinout of this chip because it's having quite a lot of pinouts. So I was concentrated on that to not fuck those up, And I didn't fuck those up, but I did fuck up these little things, which is not that bad, After all, the way I link it. This is actually a big 100 nano capacitor you are seeing there, and I use it as rails, as power rails, is legs, like that. And this is 1 or 3 microfarads here. It's not 1 microfarad, it's actually 2 or 3 microfarads. It's a little bit higher, but it's good enough. And here is a close-up actually. So this is the second chip that I put it here, and here is with the 1 kilo removed. So let me get back to the program. So this is the bit bank, the minimum of a bit bank program that you can write to drive this chip for one single display. And I'm slowly getting through the program for you to see it and to copy it if you need it. Also, I have a very good notes here while I was learning him. And you can see the way it's commanding is not I2C commanding, but it is like an I2C commanding, which is probably why I like it. I like this chip because of this mode of addressing, mode of commanding, similar to I2C. It's not exactly like I2C, but it's a bit easier to command than I2C a little bit. So bitbank program showing a number and also can dim the display. This is the second program also for this display. Bitbank program and is the original dimming program, and it's a bit more complicated. It's having way more lines than this original one. Let me go slowly through it, and you can see. But I did manage to clean all this code after I realized it was only a matter of address that was different from this code to my other codes that didn't work. And also for one single display using the library. So the next one and this was another weird thing about that's why I said this chip was weird from this perspective as well of the libraries. And after I stayed like 2 or 3 days with the libraries, I literally learned them. I stayed inside them. I looked inside the libraries headers and CPP files. There are 2 guys. One is copying the other. The newer guy is copying the old guy, but the newer guy is adding a little bit more functionality than the older guy. And I choose to use the newer guy, include these 2 files. Yes, both of them to properly work. As you can see, the 1640 is dependent on 1638. This 1638 was mentioned a lot inside the library, and probably this suggested me to look on this 1638 chip on internet here on AliExpress to search for it and to decide to buy it, and also look on its datasheet and everything. Okay, this program is using TM library master that includes 1638 and 1640. So this was my first introduction to the libraries of this chip that you can find on GitHub. And this is how I'm working these days, by the way. I'm not using the library manager from, probably this is the one, from Arduino, because it's Windows 11. My Arduino version of the program is old now, is deprecated probably, and there are other versions more newer than my version that I'm having here. And this managed library is working, but is very, very slow. I have to wait like 1 minute for it to load, pretty much to blank, to not show anything, just to load the little window to appear. And then when I'm searching for something, is also taking a very long time as well. Is incompatible, extremely incompatible with Windows 11. On Windows 7 it is working fine, but on Windows 11 it's fucked up. That's the problem. So like I said, this is the first encounter with these libraries, and I had to literally go to GitHub and download the zip file. Yeah, and here from the sketch button, I'm going to include library, and I'm going to this add zip library, and I'm searching for the zip file where I downloaded from GitHub, and I'm loading it this way. This is starting to be my default way of loading libraries, because it's much more quicker than the default of the program. Unfortunately, it's a bit more shitty, but it's good that it is there. And this is the last program for one single display, trying to use a TM16XX master library functions. So this is the newer library, the newer guy, and this is the older guy, the original guy that this guy built over this guy. I believe he is actually mentioning in his library, he is mentioning that he based everything he's having there on this other guy, older guy. So far, it is set to auto increment mode 040 on this address 040, and it cannot find or use fixed address mode like 0x44, like I did with my bitbank mode. Also, I cannot flip a single digit, because apparently this flip function is made for multiple digits. Set display to string, any number. It's kind of a hack. This thing. So I had a ton of little problems in code as well. Let me close this down, and let me bring up this file, because it's having some interesting stuff in it. Yeah, I'm not sure how good this table is here. This is probably not a good table, but it remained there because I was concentrated on other stuff. Here, this is the entire code with this library, this newer library. As you can see, it's the same naming. That's why I'm writing these notes here, because this include TM1640 is the same name here in the program for the old library and for the new library. So you cannot distinguish by looking on them. Unfortunately, that's a very shitty thing. But now I decided to remain with this newer guy, TM1636 master library. And this is doing quite a good job, but is not perfect either, especially for one digit, for one display. So what I'm saying here is that I cannot use the dimming function that I was using in bitbank mode. It cannot do it. I have to rewrite its library to be able to dim the display. But this is for only one display, and is more like a like an exercise for me to figure out what it can do and what it cannot do. There is a function in its library. It's called flip. No, I don't see it here because I deleted it. Probably I should have leave it, comment it out. Yeah, TMX. This is the library. I put a copy here of it. Let's see. Yeah, this is the one. So this is the function directly in the library that you can use in your program, in your Arduino program. So set display flipped, and the argument is a boolean, true or false, pretty much. You have to put there. This is the name of the function, and this is another function very similar to this one. Is doing pretty much the same thing. Is the same function pretty much, but they are named differently, and it's having the same algorithm inside. One is reversing and one is flipping. So they are both the same. And also the argument is true or false for both of them. I tried to use this function, this flipping function, for a single digit, and it didn't do anything because it freezed the number it was displaying. And it didn't move. It didn't do anything after that. And my assumption, my guess was that by flipping multiple digits, it was actually changing the address or the grids. So that's why my number was appearing like it's freezed, because the address changed pretty much. And what I was having on my display, on this one single display, I was having an address that was not accessed anymore after flipping. If I was flipping again, it was changing. So this confirmed my suspicion. That's why, that's how I thought about it. I literally guessed what was doing, and most probably I was right. This is another function that I tried to use. Yeah, here. I tried, as you can see, this is having, you see here is a point, a circle. You see this is called DP, or let me actually, yeah, you see this is DP, is this guy here, this circle, and it's commanded from this pin. If you are accessing this pin, you are letting or not letting this LED, this circle LED. And from this code set display string, you can add numbers and letters. That's what this function is for. But that DP decimal point was not lighting up at all. So any number that I was putting there, I was trying from 0 up. 0, 1, 2, 3, 10. I tried a lot of numbers. Nothing worked. Nothing managed to lit up that DP point. And then I looked in the function, so the actual code for set display string, and I looked inside that code, and I actually understood what that code was doing. And after looking like 5 minutes like a crazy person, I was just staring at that little code, and I was trying to figure out a way how to pretty much to understand it. And after like 5 minutes of staring on that code, or this function code inside, then I figured it out. And then I realized that all that is doing is changing numbers, pretty much. That function is changing some numbers. And by introducing a -1 number here, it lit up my point here directly from this very special function, this display string function. And I told ChatGPT my discovery, but he came with a counter-argument, and a good one actually, even if it's a counter-argument, that is kind of a hack what I did here to force it to work. And it's perfectly true. It's exactly what I fucking did. And I didn't thinking that I'm actually hacking it. I was trying to find a solution. That's what was in my mind. But this is actually describing quite correctly what I just did there, that I literally hacked this little function, to make it work for that little DP point after code reading inside TM1636 CPP. Weird. Yeah, I cannot find that function. And lastly, what this program is actually doing, all this program, what you are seeing here is actually looping, and is counting from 0 to 9 continuously. But is lighting up DP point is 1 for even digits. But by using this other function, set display digit, this function is having absolutely no problem by lighting up this DP point. I wanted very much to use this specific string function to figure it out. But in reality, you have to use this other function to lit up that DP point specifically if you want. But it's limited only to digits, only to numbers. You cannot show letters with these functions. These two libraries, the old one and the new one, they are a bit limited in what they can do. But even with these limits, you can do a lot of things with them. And they are very good. Actually, I really like it. And I based all my next programs that I did, I based them on this newer, I'm calling it a newer library, this 16x6. X6, it means is covering a lot more chips than the basic one, than the original one, this 1638. So this guy is more smarter, and he covered more chips with its library, which is very good, including my chip, Next, I jumped into 3 displays. Actually, I have the pictures here. Yeah. Next, I took out that one single display and I hooked up 3 displays. As you can see, actually, I have a picture here, close-up picture, where I'm showing the details. As you can see, all the segments of the display, of the first display, is parallel with the second display segments. And the second display segments is paralleled with the third display segments. So everything you are seeing here is paralleled from one to the next one. You can see these white wires here on the bottom and here on the top, but the common here in the middle, this is commanding from that black wire. You see this black wire that is coming from here from grid pin. So from grid 1, you are commanding this common pin here. As you can see, these 8 segments from 1 to 8, you are commanding all these 8 segments. The grid is the common here. So pretty much what I did there in my circuit, I linked this grid 1, 2, and 3, only 3 of them, to this. You see, I actually write it down on the cardboard here. Grid 1, grid 2, and grid 3, these 3 wires to their common right in the middle, they're on top, or in the bottom, doesn't matter where you are putting them. So I managed to drive with this library. I'm actually mentioning here in parallel, 3 displays in parallel, using a TM16 master, the new library, the first program to show 1 to 3 numbers on 3 common cathode 7-segment LED displays linked in parallel. It worked the first try. I didn't have absolutely no problems. So is this number 5? That's it. Is this simple? Even more simpler than the driving one single display. Here is the difference from my other program. Pretty much when you are making an object, this module name is actually the object of the class TM1640 and is accepting a new parameter here. This is the number of digits. You have to specify how many digits you have linked to your chip. In my book, theoretically, it should sense how many digits you have from the connection you made to the chip. From my point of view, of course, but apparently you have to declare it specifically how many digits. And in a way, in a sense, it's also a good thing because you can vary how many digits you can drive from this number here, even if you have multiple displays there. And that's the only detail about the first program to drive these 3 displays. The next one, number 6, also using in parallel, also using the same library, a counter demo program from 00 to 999 at 10 milliseconds per step, then repeat using all 3 digits. And this is what this picture is showing actually. Here is this counter that I made, and this is the wiring without those LEDs blinding my camera. Here I managed to use these functions, set this, the flip function and the reversed function. I managed to actually flip and reverse the number successfully. This was the function that didn't work with one single display before, both of them, because they are pretty much the same thing with very little change inside the function what is doing. The next number 8 program is using 4 display modules. So this is before I received this 4 display module, and this is the 4 display module that is, as you can observe, is much smaller in size than all these 3 older style, and this is the new style of 7-segment LED display, which I commanded from AliExpress, and they came out after my chips. They arrived later. In exactly the minute I received them, I almost finished testing them, all these 3, and that day I received this new 4-digit display. After a couple of minutes, less than half an hour, I hook it up. Here I read how to hook it up because it's having a very different way of hooking the wires up. It's exactly the same as with the 3 digits in parallel everything, but this paralleling, this wiring that you are seeing externally here is done internally inside this module. Here is with the power off to see more clearly the wires where they are going into. And yeah, here I'm actually using a 4th grid because I'm having 4 numbers there. So grid 1, grid 2, 3, and I've added this 4th one. I'm also presenting the malleability, the flexibility of the way I'm building stuff on this cardboard. You can add later, even if you are making mistakes, you can add later more stuff, more pads, more connections to your cardboard because it's pretty much for free, and you can glue on top, you can modify the shit out of it. I didn't bother with these components that I'm having here in air because they are doing their job, the functionality is there. I didn't bother with making them pretty, adding another cardboard just for them. I could have, I was thinking on it, but I was concentrated on other more critical and more important stuff like how to link everything here, how to drive the chip, etc. So I leave that as the last thing to do, and I never did it. So this is the first time when I'm using a 4-digit display, or 4 displays. I'm calling it 4 displays. It is actually 4-digit displays. I'm using the same library, the newer one here, the first program to show 1, 2, 3, 4 numbers on a 4 common cathode 7-segment LED display module. This module here is a very new component. Again, the chip was very new component for me. Linking to this older style of LED display was new for me. This is also a new module for me, very, very new. Everything is new for me. Everything is the first time I'm putting my hands on them, and I managed to make them fucking work. Also worked the first try, which is glorious. Blah, 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 blah. Counter demo program is the same thing I did for the 3-digit. I copied and changed the program a little bit. The same thing I'm counting. This is displaying 1, 2, 3, 4, the first program. I didn't make a picture for the counting. This last program here I'm having, so if you are seeing here is the program that I used in Proteus to load the Simulino, but the simulation never worked because TM1637 component is not working inside the simulator. TM1640 is not existent in the library of Proteus. So that's what this last program is here. It actually should have been the first program that I tried because that's the order of things, but I leave it as the last one there because here in the pictures I have the same pictures as here. I put some notes for the first display to be very clear what is what and where I did connected everything on the digital pin 2, digital pin 4 on Arduino, and also a close-up here what these wires are connected to, the in and serial clock there, a common ground wire, what resistor I use, what capacitors values, the positive and negative, what external 5 volts these wires are coming from, this small power supply, and also the chip pins, the ground and the positive. This wire, I use it a little bit, but it was prone to make shorts by dangling around, and I choose then to use this capacitor to clip on it directly. The 7-segment common cathode LED display, because I was having a lot of problems on deciding what type of display it can drive this chip. And that's it about the pictures inside this folder. The rest are the same that you've seen so far, and are close-ups, and they are repeating. Actually, I have this to-do thing. What to do? This I finished on this date in 19. This is the things I tried in one day. Test the 2 buttons. I also tested for 2 buttons. I believe I have a picture somewhere. Yeah, you see, I have this picture where I tested these 2 buttons. It took me a lot of hours until I realized that this fucking chip is not actually having those keyboard, if you remember, those kappa, K markings on the pins like the other chips are having. From the first try, my first encounter with this chip, I didn't realize this little detail, and ChatGPT was throwing garbage information at me. He was very sure, yes, motherfucker, you can drive buttons with your version of the chip. It gave me false hopes, it gave me a lot of false information, but in the same time, it forced me to check everything. And by checking with other types of chips from this series, I realized the difference from what I'm having and what those are. That other types, they have this special function of driving keyboard keys, but my version is not having shit. So that's I actually tested, and it took me some time, this little fucking test as well. So not for TM1614, but for other models. I specified here. Add new common cathode 7-segment display on the breadboard to have 3 displays and test the flip and reverse functions that didn't work with only 1 display. So here are multiple things to try in only 1 line, and I did all of them, and it took me a lot of time to test everything and hook up everything and to think about it. But lucky me, it worked from the first try, and I didn't have too much problems here. Also, the flip and reverse worked flawlessly with 3 displays there. Test the 4th digit common cathode. This line I actually added the last because I received that 4-digit display, the last thing, but I included it here like it's the normal flow of the events, but in reality it was the last thing I did. Test TM1614 number 1 that was burned, that I was believing it was burned, to test if it's still good. So this is the story. Let me continue with the story of the burned chip, because this is a funny story. So after I was testing this first display, it didn't work shit with the number 1 chip. I took it out, I put another chip here, I linked everything, every motherfucking wires, and there are a couple of wires it's not easy to take out. Also, it's not easy to put it back in. So this, what we are seeing here, is number 2 chip that is driving successfully this LED display and all the other displays with 3 and the 4th one. And this one. This is also the 2nd chip. I tested with number 2 until this stage, and then in one night I changed back. I took out number 2 chip, I put it on the table, I desoldered it from here and I put it on the table, and I took back the number 1 chip that I was believing it was burned because of that resistor. Remember, that was the actual problem. And I took that number 1 chip, I put it here, and I soldered it again. It drives the same 4-digit display that I'm having here as well, and it actually had absolutely no fucking problem at all. So I changed 3 chips on this board, on this cardboard. I soldered them and I desoldered them 3 times so far, and I'm sick of changing chips. I don't want to change chips on this board again. But you know, all these problems, all these issues are teaching you a lesson, some kind of lesson. And even if it's hard, like I'm describing it, it becomes something like a routine, something that is not easy. But if you have to do it, you just do it without thinking. It's like drinking water. You know, you don't think how good or bad is the water that you are drinking. You are just swallow it, and that's it. You move ahead, you move along, you change everything that it must be changed, and you move along. And also on this process, you also learn a little bit more than before. Little fucking details that are not that evident, but on the long run, it will add up. This is called experience. This is the best way I'm learning, at least, by doing stuff, by putting my hands, by soldering and desoldering and resoldering again. This is experience. This is counting up, is piling up, is adding up in the experience layers. It is forming a better artist electronist, as I am. And lastly, because I have 20 pieces of common anode, remember that this chip is not made for this common anode display. I didn't test it, although I specified, I did write here that I should test it. But before I test it, I start asking ChatGPT first what to do. If it's working, and he was throwing me a lot of weird balls. Now he was telling me, yes, you can drive the common anode with your 1640 chip. And the next round, it was throwing me the reverse ball. You cannot drive common anode because this chip is not made for this type of display. And I was getting back and forward information, and I started to look between the data sheets. As you can see in my folder here, I'm having these 3 red data sheets. You can recognize them by the color and also by the extension PDF. And I looked on all of them, and even more than this, I actually made a list of this brand chips, of these display drivers. Not a very large list, like 6 maybe or 7 chips like that, but I remained with only these 3 because this is what I used in Proteus, the first one. This is what I bought and tested here in reality, and this is my future chip that will come next. So that's what I leave here. Yeah, you see here, Proteus 9 demo portable. That's this last to-do thing is. And here, find more TM. Actually, I searched a little bit more for this, and I find these 2 libraries. I realized one is on top of the other older one, and I stopped searching for other libraries than these 2. Compile one single. Yeah, it was in question at some point in some functions of this library. And I thought I should get into the library and change it and make it my own with my name on it, but also build on top of those other guys' libraries, of course. I only add more details and more functionality to be able to test it on one single digit, and also to switch between those 2 modes, if you remember, continuous and only one single display without auto incrementing. And I give up on these 2 lines. It remains in the future if I will decide to get involved. Also, I never made a library in my life for Arduino, so this will be a first time for me to make a library, or better said, to modify an already made one, to modify it and to add more functionality to it. But it's a long but. I'm not even competent to start building it, but I had this crazy idea to get into it, but it remained there as a future to do. Maybe. It's a maybe. And the last thing to do, actually, I should have put it here. Drive the maximum numbers of displays TM1614, the chip I'm having, can drive. Use 4 modules of 4 digits common cathode 7-segment display using effectively all the TM1640 grid pins. So what this line is saying is that I should link all these grid pins, all of them, all 16 of them, to these 4-digit displays, these new guys that I have already. So pretty much I will have 4 times 4. It means 16 digits. And it means 4 displays, 1, 2, 3, 4, shape, one on top of the other. That's the project that I will discuss the next movie. Yes, I already started here, as you can see, also on a cardboard. This is the number 2 chip that I took it out. I put back number 1 on that testing board, if you remember. And I'm reusing the second chip here on this new board. And I'm repurposing these scrapped pads from miscellaneous boards. And here I didn't have this nicer pad, and I use whatever there, and also whatever here as well, for all these grid pins. And this is the segment pins here. Originally, I made it, you see, I made it nice like this originally. With equal and very large pads, very easy to connect, and also for the segments here, and these are the grids here and here. But later, I looked into my shit and I said, well, now it's a good time to repurpose all of this. These are actually cut. Here is a cut and here is a cut. You can see this is a single board, and this is another single board, and this is another single board. So I literally glued them next to each other, and I made all these 8 pins that I need for the segments, and also 16 pins for this weird ass pads. Also, these are also glued here for the power rails. This is 0 volts, this is plus 5 volts, and also the capacitors there. And also, and here are the resistors, the 10K resistor for the in clock to the positive line that is going into the pin onto the large pad there, and then 2 wires here and here. You can barely see this one, to these pads that are connecting to my Arduino board from these pads, and from these pads are also connecting to the chip pins here. And that's it. Here is an overview of the stuff that I'm building right now. It's in progress. It's not finished yet. I managed to put some wires actually right now, but and this is a beauty shot here. And the size of this board is exactly the size of those displays, one on top of the other. So this will fit on the back of them, on their pins, pretty much. You will see later how everything will go. Hopefully this will be a glorious movie. I started by working with this chip, by learning it. It was a bit more harder to work with it than expected, especially the code that I had to write, also little shits that I had to solve to make it work. Also not to give up on it, especially when I thought that thing was burnt. Now, in retrospect, when I'm building something more complex, more interesting with this chip, I realized and I start to like it. It's actually a very nice chip, and I'm highly recommending it for you to try it. Also, it's a very cheap chip. integrated circuit. Cheap. It's a very cheap, very cheap. And yeah, because it's a very cheap, I'm also recommending it as well. The only problem, it's a bit more hard to deal with, to wire it, because I'm doing the stuff that I'm doing, how I'm doing it, and it's a bit more problematic when I literally have to use all the motherfucking pins. By the way, it's having 28 pins, almost 30 pins. Almost 30 pins, it's not that fun, not that easy to link with fucking wires, and you will see what madness I managed to make, and it's in progress right now. Pretty much this is it. With this project that I'm showing you here in this beauty shot, it will use effectively all the grid segments, all 16 digits, all 4 displays in my case, and it will use the entire pinout, the entire chip I will use. And I'm very curious how this entire chip will manage to drive all these displays, because it's quite a lot of amperage there. It's quite a lot of power to drive all those displays, after all. That's why I'm building this project out of pure curiosity. It's very interesting chip. I start to like it. What I really like about it is the communication with it, with these 2 wires, the in and clock pins. This is very nice. I really like it. I really like it. It's very simple to communicate with it. Simple in the hardware side of things. But in software it's a bit more complicated to address him. But in hardware it's quite easy to plug and play the wires into the Arduino board. Actually, let me show you a small movie now in the end of the display that is working right now. And this is how it's looking. Yeah, you see here is a number 1, and the other chip is number 2 that is on my table right now. And here is the capacitor, and this is the counter that is counting like an idiot. And here are the grid lines. Like I said, it's very easy to modify this cardboard electronic board and all the wirings to it. I was saying like, it's very easy to plug in and plug out from Arduino here and there, and this common wire, green common wire. So this is how it's looking when it's actually working. Here is a small preview on my new board. This is number 2, and all the madness of very fine wiring there. Those are 10 kilo to the positive line from the in and clock. Those are the capacitors already mounted there. One 100 nanofarads and one is 3 microfarads, I believe I put there. And here is very sturdy, very stiff wiring here. This is actually keeping the chip in place. The chip is not glued, it's held only by the wires. And also this very stiff wire here as well is anchoring it, is not making it move that easily, by itself or by vibrations. I'm planning to put some glue on these wires and to properly make a distance from each other, and being glued, it will not be a problem of moving and making shorts in the future. That's my plan at least. And this is the display, how long it is. Like I said, it will be like this. It will be on top of this, and it's the same size pretty much. And in the end, you will believe this that is a module that I buy it, but behind the scenes I actually worked very hard to make it. These 2 are my notes here, how this display is linked, the wires, and this is the chip pin assignments, pin markings. Right, I also made this thing here. In a sense, I don't like it. I don't know why, but I don't like it. This is more practical than that. That is a bit confusing. I cannot quickly see the pins assignment, but for some reason this is more easy to follow and to see the pin assignment. This is it, the progress so far. This was a quick peek about it. This is the wires that I'm using. Oh, my father came last night while I was working on those very fine wires, on these wires here, and he made a cross with his fingers, and he said I'm not normal by working like this very small and very fine wiring. I'm back to the counting, that is counting like an idiot here. I'm very pleased with this project. I'm very pleased with the chip itself. I start to like it. It's a very good chip again. That's it. And yeah, this is it. Thank you very much for watching. There are maybe other details. Here I also have some programs, library to use, library functions. Oh yeah, I made this file here, how to use these functions and how to, the problems that I had. And it's good to read it, specific from this newer library, TM1636 master guy. Yeah, these are my notes. I told you, it took me a couple of days to make everything, clarify everything. It wasn't easy. It wasn't one day or a couple of hours. It was quite an extensive thing. Okay, that's it. Thank you very much for listening, for understanding, for staying here with me and learning this new chip. And I hope it gives you some ideas. I hope it is helping you some way. Even if you are having a different number chip from my version of the chip, maybe you have some other number, it will give you some ideas how yours are working while seeing my chip, how is working, what to expect from it, and how is actually behaving, and what problems you will encounter, like my problems that I have. I hope it's helping you, all this stuff that I'm making, and it's giving you new ideas. I say to you goodbye. Thank you very much, and also leave a like, and see you later on my next project or my next level of the project. All right, bye-bye from our favorite artist electronist, Mr. Q12. Bye-bye.